Hello dear students, so again welcome back to the lecture number 19 of the same chapter, that is chapter number 7. In its previous lecture we have solved the question number 2, and in that lecture we have discussed a new term that is known as altitude. Okay, and in this lecture we are going to solve the third question of that exercise number 7.3, right? But before starting the question number 3, we will discuss about another new term which is known as median. Okay, we have discussed about altitude, and now we are going to discuss about what is the median. Then we will solve the question number 3, right? So let's discuss about it. Suppose there is a triangle. There is a triangle like this. There is a triangle like this, ABC. Right? Now, suppose BC is one of its side and there is a point D which is the midpoint of BC. So D is the midpoint of BC. Or you can say BD is equal to DC because D is the midpoint of BC. So this distance is equal to this distance. So D is midpoint of BC. Understood? Now you do one thing. Join the vertex A with the midpoint of its opposite side. See, if we will take A as a vertex or A as an angle, then what is its opposite side? BC is its opposite side. Now we will do what? We will join this vertex or this point with the midpoint of its opposite vertex, that is D. So we have joined A with D, and we will get a line like this, AD. Okay, and this is the line, D is the midpoint, so you can write this distance is equal to this distance. This is clear. Now this AD is known as median of the triangle. What is it? AD is known as median of the triangle. Then tell me, what is the definition of median? How we found this median? After joining a vertex to the midpoint of its opposite side, we will get a median. So what is a median? A median is a line which joins a vertex with the midpoint of its opposite side. Simple. Again I am telling you, a median is a line which joins a vertex with the midpoint of the side which is just opposite to it. Okay, so you can write the definition. A median is a line which joins a vertex with the midpoint of its opposite side. It should be kept in your mind. The opposite side, midpoint. Okay, with the midpoint of its opposite side. Do you get this? For example, here we have found AD is a median. Suppose AC is a side. Okay, and EB the midpoint of AC. EB the midpoint of AC. That means this distance is equal to this distance. So here E is the midpoint of AC. Now what we will do? Find the opposite angle of this side. What is the opposite angle of this side? Tell me. This one, B is the opposite angle or opposite vertex of the side AC. Now in order to find median, we have to do first, we have to just join this vertex with this midpoint. So what is a median? A median is a line which joins a vertex to the midpoint of its another opposite sides. Okay, similarly here, so what we have found? Here we have found that B is another median. This is clear. Next, suppose AB is a side and F is the midpoint of AB. Okay, so here we have taken F is midpoint of AB. Now we'll do what? We will find the opposite vertex of this side AB. C is the opposite vertex. Now join this vertex C with the midpoint of AB. This one. So CF is also the median. So what is the median? Again I am telling you, a median is a line which joins a vertex to the midpoint of its opposite side. Simple. Okay. So here we have found three median. AD, okay, BE, right, and CF. Here also F is the midpoint of A. So this is all about the definitions of median. Okay. So in a triangle, how many median we can draw? In a triangle, at best we can draw three median. Understood? Like the altitudes. Okay. Now look at this figure clearly, vividly. As you can see, after drawing three median AD, BE and CF, what we have found here? We have found that all the three median meet each other at a single point, like the altitudes. There also all the three altitudes meet each other, intersect each other at a common point. Here also all the three median meet each other at a common point. Suppose the point is O. Then what is the name of this point? Then the name of this point is centroid. What is it? It is centroid. So let us write the definition of centroid. So what is a centroid? A centroid is a point or is a common point where all the medians of a triangle intersect. Understood? So a centroid is a common point where all the medians of a triangle, this is the symbol for triangle, meet or intersect each other. Okay, so this is all about centroid. Now, if in a question it is asked that draw a median from the point A. Suppose the question asks you to draw the median from the point A, then how can you find it or how can you draw it? So you have to first find the midpoint of BC. Suppose this is the midpoint of BC. Let's say this is D. Then you have to simply join AD. Now this AD is the midpoint. And also you know D is the midpoint, that means this is equal to this. In this way you can find the median of a triangle. Okay, so now let's move to the question. So now let us solve the question number 3. So in question number 3 it is given two sides AB and BC and median AM. As you can see there is a term median that we have discussed earlier. Okay, so AB, BC and median AM of one triangle ABC. So let us first draw the triangle ABC. Suppose this is the triangle ABC. Now in this triangle AB is given, BC is given and the median AM is given. So we have to draw this one, this median. Okay, since the name of the median is AM, it means we should start drawing the median from the vertex A. From which vertex? From this vertex. Then recall the definition of median. What is a median? A median is a line which joins the vertex with the midpoint of its opposite side. This is the definition. Na? So, what is the opposite side of a vertex? BC. So, here you have to find the midpoint of BC. Suppose this is the midpoint of BC. So, this point is M. Now, join A to M. Now, this M is the median. Since M is the midpoint, it means this distance is equal to this distance. Okay. Next. And these are, which are AB, BC and this M are equal to, again, another triangles PQ side, QR side and median PN. So let us draw another triangle PQR. Okay. PQ and now R. Clear? Here PQ is given, QR is given and we have to draw another median PN. right? So we have to start drawing from the vertex P. So let us find its opposite side, that is QR. Then we have to find the midpoint of QR. So this point is N. Since it is the midpoint, so this is equal to this. Okay? Now join P and N. Now this PN is the median. Right? So what is given here? Here it is given that AM and PN are two medians to the triangle. First one is for the triangle ABC and second one for the triangle PQR. Okay, and also it is given that AB side is equal to PQ side, BC side is equal to QR side, AM distance is equal to PN distance. It is given, see, they are equal, and AB this side is equal to PQ, this one, and BC is equal to QR, BC. That means this total distance. Okay. So you can represent it by like this. It is this. It is this. Suppose this is the BC and QR. So BC is equal to QR. This is given. Next, AM, this distance, this median is equal to PN. This is given. Okay. So these three things are given in the statement. Now using these three things, we have to solve two questions, or we have to prove these two statements. The first statement is triangle ABM. Which triangle? Triangle ABM. So this triangle is congruent to the triangle PQN. PQN. This is the first statement. And the second statement is triangle ABC. ABC is congruent to the triangle PQR. Okay. So let us prove it for the first statement. Right. Now, since it is given that this distance is equal to this distance, isn't it? Yes, BC is equal to QR. It is given. So you can write since BC is equal to QR. Why? Because it is given. Now we will do what? Now we will make half of it. We will multiply half here and half here. No problem at all. Okay. Now half of BC means what? The half of BC means what? The half distance. So this is the full distance. Then half of BC means either you can take this distance or you can take this distance. Okay. Since M is the midpoint of BC, so the half of BC is either this distance or this distance. Suppose I have chosen this distance. So half of BC means BM. Clear? Similarly, half of QR. Since N is the midpoint of QR, so half of QR means either this distance or this distance. For my convenience, I have chosen this distance QN. Are you getting my point? QN. So here what I have done, I have multiplied half. Okay, so now I have concluded that BM distance, which distance? BM, this distance 1, 2, 3, 4 is equal to QN 1, 2, 3, 4. Clear? Now let us prove the first one. So now we have to compare this triangle ABM with the triangle PQN. Okay. So here between triangle ABM and triangle PQN. Okay. Here for the triangle ABM, this side AB is equal to this side PQ. For the triangle PQN, this is given. Yes or no? Yes, it is given. Similarly, you can see. Similar, first statement or first condition. Second condition is that this AM, this the median, is equal to this PN. This is also the median. It is also given. AM is equal to PN. So I can write AM is equal to PN. This is also given. Now the third condition is that earlier we have proved that this distance BM, so BM, this distance for the triangle ABM, this distance is equal to QN, this distance for the triangle PQN, isn't it? Yes. So BM is equal to QN. by proved. So this stands for side, this stands for side, this stands for side. So for the triangle ABM, if we consider this side, this side, this side, so by S congruency, we can write this triangle is congruent to this triangle. Hence, by S congruency, triangle ABM is congruent to the triangle PQN. Hence, we have proved the statement number 1. Proved 1. Do you understand it? Here, it is given this side is equal to this side, this median is equal to this median, this side is equal to this side. Now we will do what? We will make half of it. So half of it BC is BM and half of QN is QN. Then we have compared these two triangles and proved by SSS congruency that these two triangles will become congruent. Okay? And now let us move to the second bit of that question. So let's prove the second statement. So the second statement that we want to prove is triangle ABC. This triangle is congruent to the triangle PQR. Okay, this triangle is congruent to this triangle. We have to prove it. How? Let's prove. Okay, since from the first statement we have proved that triangle ABM, this is M. Okay, triangle ABM is congruent to which triangle? To the triangle PQN. This is already proved. Okay. Now, according to the exam 7.2, if any two triangles are congruent, then their corresponding angles must be equal. So, if we choose this angle for the triangle ABM, then and this angle for the triangle PQN, then we can say that this angle is equal to this angle because they are congruent. So, directly we can write angle B is equal to angle Q due to axiom 7.2. They are the corresponding parts of congruent triangle. Simplicity. Now, in order to prove this statement, we have to compare the total triangle, this triangle, with the triangle PQR. Okay. Between triangle ABC and triangle PQR. See, it is given AB side of the triangle ABC is equal to PQ side of the triangle PQR. It is already given. AB is equal to PQ. So you can directly write AB is equal to PQ. This is given. Second statement is for the triangle ABC, BC is equal to for the triangle PQR, QR. BC is equal to QR. It is also given. Suppose I am writing this in the third condition. BC is equal to QR. Then the second condition is for the triangle ABC, this angle is equal to for the triangle PQR, this angle. Why B and Q are equal? Tell me. Since we have proved it from the first statement, the two triangles, small triangle are congruent, so their corresponding angle must be equal. So we have proved that B is equal to Q. So for this condition, we can write angle B is equal to angle Q. Why? By proved, and it is given. So what are the three conditions that we find? We find for the triangle ABC this side, and this angle. Now this angle is the included angle or not? Yes, it is the included angle because its two are correspond to two sides. So by SAS congruency, these two triangles must be congruent. Hence, by SAS congruency, we can write this triangle ABC is congruent to which triangle? PQR. This is the proof for the statement 2. Okay, now this is done.